Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
Hello and welcome to another edition of the Web Platform Podcast, episode number 164. Today we're talking about Cypress.io. On our panel and hosting this week, Leon Revel, and returning, Eric Isaacson. Hello, Leon. Hello, Eric.
Hello. Hey. Good to be back.
Hello, Eric. Yes, so good to see you, kind sir.
Yes. You look very waveform-like, but...
well, the joys of, mystical waveforms and all the things they do. And before we get into the fact of how one might test a mystical waveform, we're going to throw it over to Leon, who's going to talk about This Week in the Web in 2 minutes or less. Leon.
Thank you, Justin. So first of all, Node 10.5 has just been released, which includes worker thread support, which is under an experimental flag, so that's quite exciting. Face API.js, which is a library built on TensorFlow.js, has just been released, and that provides an API for face recognition in the browser, which is also pretty exciting. PouchDB 7 has now been finally released, and that removes WebSQL, the promised polyfill, and moves over to using the Fetch API, which is really cool. The JavaScript V8 engine 6.8 has just been released, and that's got reduced memory consumption and several performance improvements. And Justin, I believe you've just released a new web component which allows you to visualize 3D STL files in the browser with ease, which looks really cool. So nice to see that. And the Node security group is now chartered. It's another bit of news there for you. So don't forget to check out all the links on the website for This Week in Web. Thank you, Justin.
Thank you, Leon. Did not realize you stuck my web component into that list. That's funny. For those of you who trying it, do file bugs. Justin likes bugs. Then I'll try to fix them. But other interesting things happening on the web this week. And it's summertime, so all the new fanciness comes as people write code from the beach, or at least that's what I picture it as. But we're not talking about writing code at the beach this week. No, we're talking about Cypress.io. And it's a pleasure to welcome our guests, Brian and Gleb. Brian, Gleb, welcome to the show.
Good to be here.
Thank you for having us.
So, for those out there who may not know who you are, introduce yourselves. Tell us a little bit about you.
Sure. My name is Brian Mann. I'm the founder and creator of Cypress, and it's been a project that has taken up most of my time for the last 4 years.
I'm Gleb Bahmutov. I'm VP of Engineering at Cypress, and I spent 1 year, happy year, working at Cypress, and 1 year before that using Cypress.
Fantastic. So for those out there who don't know about Cypress, how about a brief overview? Like, what is Cypress? How would I, as a web platform developer, maybe want to use it?
Sure. I mean, Cypress is a tool built by developers for developers and QA engineers, really anyone that's working on the web, and you can use it to do a form of end-to-end testing. Traditionally that's how it's used, so it's most often compared to Selenium. So, we've created, a really great experience that gives you a way to easily download and install Cypress. It's distributed through NPM or just direct download. Helps you onboard. You can generally write your first passing test in under 5 minutes. And, we try to create an experience that's like really easy, understandable, like simple commands that read like English. And as the tests run, you can see everything running in real time. We give you like a GUI so that you can understand, the state of your application. We do time traveling so you can like walk back in time. And basically just like put you in an environment that's really comfortable, that mimics the way that you would do your day-to-day development. And then, as you build up a suite of tests that are running longer and longer, we also have a dashboard component, which is an optional sort of companion service on top of the test runner that records everything that happens when it runs in CI and gives you feedback about, so you can understand, what test failed. You can watch a movie, see screenshots, and soon to have analytics and things like that to understand what tests are flaky and all kinds of cool things.
So it's been a while since we've had you on the podcast. We talked about Cypress in 2016, I remember. May, I believe, and that's when I think Amal started around then. Even being a regular on the show. And it's evolved quite a lot from what I can see. looking at the framework itself. Can you kind of give an overview of how it's changed over the years and where you saw gaps and how you filled those gaps?
Can I give
Yeah,
a
that's
quick
great.
answer, and then Brian can go into details?
Sure.
Since 2016, Cypress came out of a beta, so now there are no restrictions. Everyone can use it. It went open source, and there are no barriers.
Yeah, I mean, to Gleb's point, that's definitely the biggest change. That was actually in 2017. It was October 2017, so about 8 months ago or so. Yeah, uh, in some ways, it hasn't changed at all. When I originally came up with the idea of Cypress, I was sitting at JSConf, and I had kind of like this idea for a long time, but I was trying to come up with like an interface for this, and like I sketched out sort of what the initial runner would look like, and it has by far stayed pretty true to that. Of course, internally and structurally, the architecture around it has really just changed dramatically. I mean, what took so long was having to reinvent the architecture by how we actually automate a browser and sort of invert the process by which it's traditionally done. WebDriver or other tools like Tess Cafe are a remote command interface where you're sending commands over the network to basically some type of server that has a privileged connection to the browser that's able to implement natively for each browser those automation commands. And what I was really interested in doing was flipping that on its head and creating an architecture that worked in reverse, where the test itself would actually run in real time in the same run loop as your application code, but then still have the ability to break out of the JavaScript sandbox and still access those privileged APIs. And so, making that work was of significant technical challenge, made more complicated by some of the origin security rules that all browsers must play by. And it took us a really long time to sort of figure out how we could play by those rules so that your application would behave correctly, and yet still pull this architecture off. And it involves a lot of very crazy like proxy rewriting, certificate authority signing, dynamic certs on the fly. It involves things like automatically like stripping out frame busting and click jacking and some sort of low level security implementation details in order to make this work. But so I would say like the way that the product has matured, in the last few years is obviously it went open source, so it took us a lot to like figure out how to structure our repos and our packages and how to break all these things up into different components, but yet build and have them all together. It took us a really long time to figure out how to test Cypress in a way that like it could test itself. It's kind of funny, like as you're building a testing framework or test runner or whatever, in the early days, it's kind of like evolution, where as different pieces are coming together and the system is becoming more complex, you have like one approach because it's sort of being built, but then it reaches like a point of maturity and you realize like you can actually use it to test itself. But if it was still like in flux or still being built or not fully fledged, you couldn't use that. So even just our own way of managing Cypress has just evolved tremendously over the years. Like our build processes and how many tests that we run just in our own like CI platform has changed. We've added tons of different commands, and recently we've really started tackling some of the hardest things that users have been asking for a really long time. Things like native events and parallelization, cross-browser support, that type of stuff. So we're really excited about some of the big features that are about to land.
It sounds like you've been really busy getting Cypress to where it is today. But just to step back a little bit, just for anybody who's never kind of come across it before, could you maybe compare it to some other competitors? For example, how does it compare to something like Nightwatch or Tess Cafe or Source Labs? How is it similar? Is there any kind of selling points over those different things? Just to maybe give people a bit more of a picture as to exactly what Cypress is and does.
Sure, that's a great question. I mean, we'd really just have to kind of go through them one by one. Like, Nightwatch is a JavaScript testing framework that is a wrapper around WebDriver. And so really to kind of like understand the big players in the space, we have to like add some definitions. The tool that people are most familiar with is a tool called Selenium. But Selenium itself isn't really anything. It's back in the day, it was like a separate product. You had like Selenium RC. You had a group of individuals that were really interested in sort of like defining what the specification was in order to remotely drive all these different browsers in a consistent way. So they kind of outlined the spec. That product matured. And then all of a sudden, sort of, we have this new word being introduced, which is WebDriver. And WebDriver is also kind of like, it's not really a thing. It's more like a concept. Well, it's a specification. And then, Selenium sort of describes like the all of the different pieces of like that ecosystem. But if you were to actually like download Selenium, all it really is, it's a proxy server written in Java, and the vast majority of the time it's not actually needed. It's really only needed for Internet Explorer driver, because Internet Explorer driver only accepts localhost connections, and it's primarily used by like service providers as like the central hub to have access to their to spinning up instances like Sauce Labs or BrowserStack. So if we sort of put aside Selenium for a second, WebDriver is really the main thing. And what WebDriver is, it's an official or now officially adopted specification that describes a series of endpoints. And those endpoints act as effectively like a lowest common denominator by which all the browsers must be able to implement the base WebDriver rules. And you can look at them. All it is a JSON API, and you send commands. You send normal HTTP requests per that specification, and then what you're guaranteed is that the thing that you're sending it to, the actual driver, is going to implement this protocol and send you back what you expect and normalize it in such a way. So WebDriver is a specification, but the actual things that implement WebDriver are like the actual official browser drivers. And most browser drivers are written by the teams that build the browsers themselves. So for instance, with Chrome, you have Chrome driver. With Firefox, you actually have Gecko driver. With Edge, you have Edge driver, and so on and so forth. And what those drivers are is they are actually just simple HTTP servers that have, it's just a RESTful server that accepts the requests that match the WebDriver specification, and then each one individually automates the associated browser in its own unique way. Firefox now uses what's called Marionette, which is an abstraction over their remote debugging protocol. So it's actually like 2 layers of abstraction. Chrome and Chrome driver uses the remote debugging protocol, which is the same thing that DevTools uses, and it's the same thing that Puppeteer does, and so on and so forth, right? So coming all the way back out, that's sort of like zoomed in. Like what Nightwatch is just a JavaScript testing framework that gives you an API, a DSL, and that DSL is then translated into network requests that match the WebDriver specification. And as part of all that, you would have specified what browser you wanted to spawn, and so those requests go to the actual browser driver. Then the browser driver communicates with the browser, and then back and forth it goes. So the vast majority of the tools out there are all under the umbrella of the WebDriver/Selenium ecosystem. Virtually all of them are. And that's how it's been for a really, really, really long time. But in the last year, the last 18 months, there are really like two, or I would say three new tools. The first one is Puppeteer. And what Puppeteer is very, very simple. It's actually much simpler than that whole ecosystem we just talked about. Puppeteer is simply a node APIs, so a DSL, and it is a DSL that wraps the low-level remote debugging protocol that Chrome uses. So instead of using Chrome driver, it's simply just communicating directly with the automation APIs that Chrome itself serves up. And guess what? Chrome itself serves those up over as as a server, as WebSockets, right? Like it itself opens ports. Well, you pass a flag that tells it to do that, and it basically accepts connections, and that's how you issue it. It's the same thing that DevTools uses, etc. But Puppeteer itself is really just an abstraction over this. So you only get what the underlying protocol itself supports. And the Chrome debugging protocol is vastly, vastly more powerful than the WebDriver specification, because the WebDriver specification is like a lowest common denominator. And it's also like a series of abstractions that don't necessarily translate directly into all of the power and capabilities that you have. So that's Puppeteer. Puppeteer is amazing. It's excellent. They did a phenomenal job. But they're not like adding anything new. Like for instance, this power has been there all along. And what Puppeteer does, tapping into those remote debugger protocol methods, is the same thing that Chrome driver does as well. It's just that Chrome driver is a RESTful server that's restricted to the WebDriver specification, and Puppeteer is you get the whole nine. And by tapping directly and exposing all of the power of the Chrome debugger protocol, which is awesome, the downside of that, or the flip side, is that it will only ever work for Chrome. There have been pushes to try to normalize the remote debugging protocols themselves, but no vendor is doing this. And that while some things are similar, vast majority, the implementation is completely different. And because of that, there's no way to like get that power magically on other stuff. Of course, that may change in the future. So that's Puppeteer. So that's like the first new thing that's like come out that people have really started adopting and using. And the second thing is Tess Cafe, and the third thing is Cypress. And all of us, don't use WebDriver. We deviate from it, and therefore we have completely different rules and completely different, expose different capabilities and features. Now, Tess Cafe is interesting because, whereas Puppeteer whereas WebDriver and Puppeteer and Tess Cafe are all a remote interface, we're the only ones that are the exact inverse of that architecture, where we're inside of the browser escaping out, and everyone else is outside of the browser sort of evaling in. And Tess Cafe is sort of also different from both us and the others, in that they have properties that make them similar to the way that Puppeteer or WebDriver work, but also have properties that are actually really similar, and strategies that are really similar to Cypress. For instance, they're also a highly complex web proxy that alters the traffic. They effectively rewrite all of the different host objects and polyfill and monkey patch, basically everything in JavaScript, because they force the entire visit experience through their own local host server that they spawn that sits in the middle, that basically captures all of the traffic. Very interesting. I mean, we are very, very positive in all of this, right? So I'm definitely not gonna if you've tried Cypress and something that we've done, in some ways, Tess Cafe has richer and better APIs than us, same way that Puppeteer has. We have sort of different selling points, and that we are of course always expanding our APIs and making them making them richer and better. But there's definitely, trade-offs to Cypress that you wouldn't necessarily find in the other tools. So, I mean, I think it's really just like what works for you is what works for you. But, if you wanted more like specific examples, I'd be happy to go into it. Like there are likely very specific use cases where one may be better than the other. But, I think we all like look at each other and we all take, inspiration from things. And so I would say like the space overall is very healthy and it's evolving quickly, which is a win for everyone.
That's awesome. Some of the things that I liked, especially the timeline, was very interesting to me. One of the things I struggle with is I'm using Sauce Labs a lot mostly, but one of the things I struggle with is IE11 testing. So when I go in there, I need to test, God help us, on Windows 7 and Windows 8.1 sometimes. And I mean, Sauce Labs allows me to do this pretty well. What's the cross-browser story for Cypress moving forward even?
Yeah, I realized that I didn't actually introduce Sauce Labs in that long debate. So just real quick, what Sauce Labs is, what Browser Stack is they are cross-browser infrastructure providers. They have access to the gazillion devices, the gazillion operating systems, and browser version combinations. Obviously, trying to manage that infrastructure yourself is like, you don't want to do this at all whatsoever. And so they give you access to spin up those browsers. Well, that's great, but then there needs to be some type of negotiated API that can spin up these browsers, and you have to automate them, and you have to automate them through the web. And so that's also like what WebDriver covers. By having like a uniform specification, they're able to expose a single like WebDriver hub or Selenium hub, if you will, and then you get access to spinning all that stuff up, and then you pass them API keys, and they bill you, et cetera, et cetera. So that's how that story works. Now, I have sort of my own personal opinions on where the industry, what trends we're seeing. One of the things we've always done at Cypress is like try not to build a tool for ourselves. Now, we're in an amazing position because like we get to use our own tool and we're all developers and we get to like have opinions about this thing. But ultimately it just comes down to like, what do our users really want? What do they say? And we have phenomenal relationships with a great number of our users. We get to see Cypress scale from like a proof of concept to like being distributed to like dozens of developers and tons of teams running like 1 million tests a month. So like we really get to see it fully baked all the way through. And then by like building features to that, like we know that we're always like responding correctly to like effectively what the market wants. And we definitely do see demand. Like people do ask us about like, what the story is around Internet Explorer, IE11 and support. But I would say that as time marches on, that is becoming less and less. And so for us, adding IE support is actually not a priority. I totally get that some people, when they hear that, they're like, oh gosh, I like would never use a tool that doesn't support this thing. In our experience, there are other higher priorities that like cover a larger market that are like bigger wins. For instance, adding mobile support is much, much, much higher priority to us than adding IE. Writing a comprehensive, hundreds of tests, which is sort of the norm. Tests that take generally between 10 and 20 minutes to run in CI serially is the norm. And it grows around, 20% a month per team is the norm. Getting all of those things to run consistently where you have a clear idea of where something failed is a non-trivial task. Just doing that once in like a single browser is difficult. And I totally understand the draw to writing a single set of specifications, single set of tests that can run on 12 different browser combinations. In practice, there is such an exclusive market for that where there's only a tiny amount of users who actually need that. And there is this compounding law of diminishing returns when you do that. For instance, if you have 500 tests that run in Chrome, and it effectively tests every single permutation and state change of your application. Likely that's not enough. There's probably going to be even more, into the thousands. When you take that same test suite and you run it in a different browser, you're effectively not getting any additional test coverage for probably somewhere in the like mid to high 90s of all of that work. It's basically effectively waste. And the only additional bits of coverage you're actually getting is testing the different implementations between the browsers, like likely a few percentage points here and there for different ones. Now I know, like, you know, but it caught like this bug and this was like a big deal and et cetera, et cetera. No doubt that stuff happens and that stuff is important. But what I'm kind of getting up to is that likely a better strategy, and one that effectively gives you the same amount of coverage without involving like combinatory explosion, where every test suite for every browser and every browser combination and every browser operating system and on and on and on and on. Like, instead of running 30 minutes of tests for all of those and just racking up like gazillions of, you know, hours doing all this stuff, likely a simpler approach that is just as effective is like just running like a dozen, or running like just the login on another browser, and potentially introducing like visual regression, screenshot diffing. And if like the main stuff passes, then you didn't do something that like is going to break your entire app for every single user. And if it looks okay, then you're probably okay there too. And that is a much simpler and a more effective way to basically approach all of the other like sub combinations.
Yeah, I agree with you. I mean, in an ideal world, I think that's great. I think that there might be a place where Cypress could integrate with another tool that does this. For now, I think that a lot of the things that I find in those browsers, and I don't test every single browser. I have at least a few browsers that we support, and I test in those, and I only test when we do a release. So I'm not going to run those tests necessarily every time I do a build on my dev machine. So I agree with you on those points. A lot of the things I'll find in these older browsers, though, and I only go back as far as IE11 at this point, which I'm kind of lucky in that sense, is I'll find a lot of CSS issues. I'll find there's certain JavaScript pieces like object.keys isn't supported, or some actually it is supported in IE11, but regardless, I'll find little things like that I'll have to polyfill, or I'll find visual things that happen. And one of the things I've been searching for is something that can test visual snapshots and go through those sort of things at an automated level. Does Cypress try to handle this at all, or do you think that there's a place to integrate with other tools for this?
Absolutely. I mean, that's a phenomenal question. So yes and yes. And by the way, I totally agree that visual regression testing, especially for cross browsers, is I think a bigger win than the functional stuff, where you get more coverage and more value out of it. You just still only need like a handful of screenshots to effectively ensure that the major parts of the layout are correct, right? And even like the object.keys part. I mean, I think like you're sort of like hitting on it, that if you just run a few things, you sort of can ensure that like the big existential, like, is the page loading or not, you can get past that, and that offers you a high amount of confidence with very little effort, and then you're not trying to like make hundreds and hundreds of different combinations of tests work. I would also just say that, like, as you said, releasing, that's another viable strategy. I mean, like where you just run the big stuff on the releases, but none of it is like free. Like, you could also just do manual testing on those other browsers, and that would effectively also cover it. So it's just there's going to be different strategies for different organizations. That's completely based on their markets, what kind of applications they're building, what type of users they're using, what their resources is, whether they have dedicated QA engineers, and even sort of their resources in CI. Okay, with that said, the visual regression testing. So yes and yes. Right now, Cypress takes screenshots. It automatically takes screenshots on failures. And with our latest major release 3.0, we did a ton of work, like months of work to make the screenshot capabilities of Cypress like really, really, really good. In some ways, like already probably the best there is for very specific architectural reasons. So in Cypress, you can take a screenshot. Not a screenshot. You can take a full page screenshot, so like we'll automatically scroll and stitch all the images together. You can also take an element screenshot, same principle. We will scroll, we will automatically strip out everything that's not the element. And in doing this, we learned all kinds of things. That first off, screenshots themselves are highly, highly non-deterministic. And what I mean by that is that like even forcing the browser to create it, to basically recalculate its layout, and what we've called painting before in performance doesn't actually mean that the browser has rendered. And what I mean by that is that like literally you could say, do the thing, click the button, whatever, network requests go out, React has rendered, but the browser has literally just not actually rendered that frame. And it itself does like internal optimizations, at least Chrome does. Not to necessarily. So even though it'll like tell you, oh yeah, this element has this height, and it really has this background color, and like everything from what you can tell from what JavaScript is supposed to use says this thing has rendered, but it literally has not rendered. And it's far slower than you would like your wildest dreams would imagine, because like the actual screenshot taking process is asynchronous. It takes at least 100 milliseconds, and in that time, like 50% of the time, it still has not actually rendered what it has said, what has effectively recalculated. And so we did lots and lots of things to guarantee deterministically 100% of the time that in fact the browser has rendered whatever those latest batch of changes were supposed to be, rendered. And then we do all the stitching and everything else. So all of this is the prelude to us doing visual regression testing as like a first-class citizen directly in Cypress. So we believe like the biggest value here is really just about baking this into the process. Because like we're the tool that owns everything from top to bottom, right? Like we know everything. We know the testing framework. We know all the assertions. Because we're in the same run loop as your application, that means that we know and can react to every single event synchronously, immediately, the moment that it happens. It's literally impossible for us to miss anything that happens inside of the application. And because we're effectively the tool that's controlling all these processes, all of it can be synchronized together, and the end result is that you can have deterministic screenshots. That puts us in a position to, be the thing that takes the screenshot, captures the bytes accurately. With that said, we just write them to the file system. So if you wanted to use, another service, whether it was Percy or whether it was Applitools, Cypress is open source. It's an ecosystem, and you can go ahead and use whatever it is, whatever other tool that you want is. We feel like the biggest value here, and the thing that like works really well for our users with what we understand, how they like to run Cypress, is where screenshot diffing is baked into a PR flow integrated into GitHub, where the screenshots are not checked into source control. Of course, you could do that, but unlike functional tests, a screenshot diff requires a completely different flow. In a functional test, the test should never fail. So if it runs in CI and it is breaking, that should always be, as long as you've written deterministic tests, you have a deterministic testing framework like Cypress, that action needs to be taken. And someone has to fix the code. Something is wrong, 100% of the time. CI fails, don't deploy, take action. But in a screenshot test, visual test, that is most of the time not the case. It could just be that the button changed color, or the footer changed, or heights, widths, whatever, that didn't functionally affect it at all. And if you checked into source control and you basically raised a red flag and exited with a status code of 1 in CI, well, so now someone's got to go in there, someone's got to figure out, is this a regression or is this an acceptable change? And then capture the screenshot, and then you have to capture it in whatever it was taken in. So like, if it's running in Linux or something in CI, that may be a different machine that you have now. You could be dealing with like screenshot resolution problems, whatever, DPIs type stuff. You could be dealing with just, interpolation of like the pixels. And then you'd have to check that into source control, and then you have to run a new thing in CI. And like that process is horrible. It's terrible. It's not good at all. So like where we think the service area that like you effectively have to have a service is basically for something else to keep track of like what all the bases and what all the masters are, and taking into account the branching, basically the way that we do feature branches, all that has to match up, right? That like this thing, was branched off of this other thing. So now there's a new set of masters for this branch, but a different set of masters for a different branch. And that when something goes wrong, instead of failing the build, instead of like failing CI, you basically just bring those differences up to the users. You give them side by side and basically enable them to like accept or deny. And if they deny, okay, that's an actual failure. But if they accept, then you can record the history of that. Then the build passes like it's normal, and then you have a new set of masters that then the next subsequent diffs are against. And that's effectively best left up to a service as opposed to, source control local.
Yeah, I think there's a lot of power to having your testing with the code, like you're saying. I've heard though from other developers, like especially some Java developers, that you want to keep your tests separate from the code base. I don't necessarily agree or disagree, but have you guys heard any contrary opinions to that, or to your stance either?
No, I mean, definitely not. Or at least the way that people use Cypress and the users of Cypress, it's part of the official code base. This once again, it really just goes back to process. It only makes sense for it to be part of the code because if the tests are describing the behavior of the code, and because like we're all on disparate teams and we generally do feature branching, the tests need to always stay in sync as the code, mutates as it evolves. And by doing that, then it's always lockstep. But if it's lagging behind or it's synchronized asynchronously by someone else, then therein lies like really the entire problem that shift left, is trying to solve.
No, that makes total sense. As far as like you said in there that that you've experienced where some of the some things haven't been loaded in other frameworks, and Cypress handles that. I've encountered that actually with end-to-end testing for various component systems like React or Vue and web components as well. Like, and how does Cypress enable like testing these modular DOM structures? What's the differentiator between you guys and the other competitors in that respect?
In regards to trying to unit test the components or testing just the whole system like a normal, like acting like a
specifically
user?
For me, I've encountered this with end-to-end type of testing, because unit tests, I'm typically not going to interact with other components. So like if I have multiple components on an end-to-end test that are integrating with each other, how do you sort of manage those modular structures inside of Cypress?
Yep. So I guess I'll answer that in 3 parts. The first is that even though like we're most often compared to end-to-end testing frameworks, and of course that's the primary use case, because of Cypress's architecture, it's in just a completely and totally different position to do totally wildly different things than any other end-to-end testing tool. And so I sort of like answer the question of like, how do you write good end-to-end tests? And it's like, well, don't write end-to-end tests, write more like integration/unit tests and use the same principles that we've used to write really good, effective deterministic unit tests forever in Cyphers. And it's like, well, what do you mean? Like, give me an example. And so the first example is that you can just do straight up component testing in Cyphers. Because we run inside the browser, you can just import your Vue components or your React components or your Angular components straight up in your spec code and mount them or render them inside of where the application would normally render. So there's no URL, there's no server, there's no whatever, but you can still have flawless access to the DOM. And then you could do either straight up method calls or just pass state, whatever it is that you would normally do in a unit test, or you can kind of like use the like end-to-end type, click, drag, trigger events sort of things. You have the ability to do it both ways, and like we're the only one that can ever be in this position because of the architecture. No other anything based on WebDriver or anything else. It's just not possible in order to do this. So basically, that's one thing that many of our users take advantage of, is that they write just a few end-to-end tests and then they use Cypress for all the unit tests, and you can see everything. You can take screenshots. You can do all the things that you have access to. You still have all of the dev tools and everything else. So it's like fully real and baked, but it's just specific components as opposed to the whole thing. Now, switch to actually answer your question, like how are we able to do things better? Well, the difference is because we know everything the moment that it happens synchronously. So I guess I'll say with a caveat that like we're not quite doing this one thing I'm about to mention today, but like we've already started work on it, and this is one of the things that we've just learned through years of trying to do this and trying to make things deterministic. And so an example would be like you use a command in Cypress like set.get some button, right? And you auto, and then like in Cypress you give us the assertions, and commands in Cypress work like a stream of events where instead of commands resolving independently of one another, they're able to like look downstream and build up like this big picture of this thing that describes the state of your app. So like, okay, there should be a button and it should have a parent, and the parent should have these specific attributes or classes or whatever, or contain this text, et cetera, et cetera. And then what it does is it basically figures out, okay, I have all of these things. I'm now going to block until all of these things are present, and all of these sort of like default assertions or explicit assertions you've added are all there. But the biggest difference is like it would be probably possible to get that in other testing frameworks, but like the biggest differentiator between us is that when you have a remote command interface, which is what every other tool is built on, whether it's Puppeteer, whether it's anything else, the state of the browser can never be 100% deterministically known. And what I mean by that is that like it's like you're on Earth and you're asking Mars what the state of a coordinate is. Well, it's got to take time. It's got to travel. It's got to go all the way to Mars, get the answer, and then it's got to come all the way back to your code to even figure out like, was that the right answer or what's not? Well, in all that time that it takes to travel there and back, there's change, there's events, there's mutations. It's not the same anymore. And so if you run the same two tests, there is no guarantee that you're going to get the same result. It's non-deterministic. And this is fundamentally the problem. And it cannot be fixed. It's architecturally impossible. It's just a computer science problem. And by inverting it, by us being inside of the browser at all times, witnessing and being privy to every single event that fires synchronously, for us, it's as simple as, oh, if it's not there, just add a mutation observer. And then the moment the DOM changes by your application code, immediately synchronously run all the assertions. So that if even for the tiniest little second it was correct, we'll always 100% of the time pass at that exact moment. It's basically like, you expect your code to run in a certain way, right? Like top, bottom, and it's that part is deterministic. And you want to write your tests in a deterministic way to where you always get the same result so long as that thing actually happens. And that's really like the key. So anytime an event fires, like we know it. Even when we're going outside of the browser, because the browser itself is still a security sandbox. And so like we try to do as many things as we can with just native JavaScript, which gives you the power of everything. Like you can spy, you can stub, you can change time, you can fire any type of arbitrary thing, you can wrap objects, you can tap into native objects, you can just modify like the state of your view stores or your Redux stores. You can just do whatever it is that you want because you have total access and control. But we still need to sometimes go outside of the browser in order to access higher privileged APIs. But even when we do that, it's still a much better architecture because we can do things like just freeze the DOM. We can literally just stop everything from happening. We can prevent every single callback from firing. We can pause every single animation. We can just disable every single animation. We can even know, like, if when we go fire this event, if somehow something did change in the DOM when the event comes back and actually gets created, we can automatically just cancel it and just, replay the event if we wanted to. Like, the position that we're in order to understand everything that happens in the app is just, it's just a tremendous advantage when it comes to running, end-to-end tests that aren't flaky. So in a nutshell, that's what makes us really different.
Yeah, I think it's pretty exciting. It's very different than I'm used to, for sure.
So unfortunately, we are running up against time. So I'd like to ask a bit about something you mentioned earlier. So you mentioned something that's kind of a higher priority for you at Cypress is mobile support. Could you just talk a little bit about what that might look like and kind of where it might be on your roadmap?
Sure. So right now, like the Cypress GUI runs inside of the browser, so that the experience is all seamless under one interface. What we're doing is we're actually pulling the entire GUI out of the browser and into the test runner, like the desktop application, if you will. What that's going to do is that then it's going to give us the ability to just modify using like the mobile emulation APIs or even just the window itself. We can effectively modify it natively so that things like the new JavaScript screen APIs are all the correct dimensions. Using the mobile emulation APIs, then we can use all the power of Chrome in order to simulate all these things. But furthermore, what we're doing is basically the architecture is not changing. It's really just where we're moving the display of things, and we're moving sort of the internal event bus of Cypress. So it's all staying the same, but we're just pulling it out, putting it in another place, and that's what enables us to do the mobile testing. So that's like part one, and then part two is I think I mentioned it earlier this podcast. It's just we're adding native event support to everything. So that means that you'll get all the taps, the swipes, all the things that enable you to correctly test a mobile browser. The actual spawning of the browser, that's the easiest part, and there's nothing we need to do. There's no changes. We just simply add that.
Cool.
So
that sounds really good. Is there any other kind of big roadmap features you'd like to talk about before we finish up the show?
So the big features on our roadmap, immediately the closest one is running your tests in parallel. So imagine you are running a CI, you have hundreds of tests. Why should you run them on a single CI box if you can easily spin 4, 10, 20 boxes? Now, you don't want to configure each box, right, separately, so it runs on a subset of tests. So we're going to offer this as a part of our API, automatic load balancing of all your specs. And you don't have to configure anything. You just run your test on CI, and they automatically get prioritized and split, so they all finish faster. So that's coming, and that's pretty much
awesome.
done.
I didn't get a chance to look at the CI stuff, but when you have that running, do you generate artifacts that have the timeline where you can go back through the timeline and the artifact?
So not yet. We've been talking about how to expose all those events. There are a lot of events. So if you want to recreate that time traveling debugger timeline, it would be difficult right now. But we do generate the video by default. We do take screenshots. We take screenshots automatically on failure. So you still have all the test artifacts from your CI. You just don't have that interactive experience.
Well, it looks like we're just about out of time.
Yeah, I mean, I just want to say that one of our goals here at Cypress is to grow, a large and rich open source community, get more community contributions. So that's something we're like interested in sort of managing better, right? So I think maybe if you're listening, you can look towards us by the time this is published to come and find us if you want to contribute, and like we'll get you in like our Slack channels, and we will basically try to hold like weekly webinars where we sort of talk about the initiatives and like the development activities that we're looking to try to do. And I think like maybe the bigger thing is that we just closed a round of funding led by Los Alos, a VC out of Florida, and Bessemer, and we are definitely hiring any senior JavaScript engineers, DevOps, designers, stuff like that. So if you want to come work on a really cool piece of technology that other developers use and love every single day, then come work with us.
Brian Gleb, thanks so much for being on the show. If people wanted to contact you, where would they find you online for things?
Yeah, I mean, you just want to go to cypress.io on the web. We have a really active Gitter community, right? So we have a chat channel in there, and there's always someone from one of our team on there answering questions, sort of playing traffic cop. And of course, our main GitHub repo at cypress-io/Cypress, and that's where we do all of our PRs, do all the issue tracking, everything else. So yeah, just all the normal places.
Yeah, go to GitHub and give us a star. Help other users find us.
Fantastic. Well, thank you both so much for being on the show today. It was fantastic. And with that, we will round out episode number 164 of the Web Platform Podcast. Today, we talked about Cypress and all the wonderful things you can do in the browser to test all the code and all the things. Join us next week when we talk more things web, more things web platform, and more news. Thank you so much and have a wonderful rest of your week.